12 by 20. That's a Stirling formula. I chose this fairly carefully, so there was a round number. Might not be the same in an exam. And then all you need to know is, since it is at the isocenter, you need to know the TPR and the various output factors for the field size, for the equivalent square that you have. The table does not have a column for 15, it has one for 14 and one for 16. I hope everybody is happy with interpolation between the two. I mean, since it's exactly the middle, that just means the mean of the two, but if it were 14.5, then you still need some kind of interpolation. Is that everybody okay with that? Okay. Then this is this, you know, starting with the simplest possible point. And the second one is beginning to be a difference. Now you notice the second 10 deep on the central axis at 100 centimeter SSD, which means that the geometry is not the same as this one. The geometry is now more like this one, because the phantom is now here, and the point of calculation is now there. 100 centimeter SSD plus another 10. Okay, anybody had a problem with this part of the question? The difference between the two is that if we always remember that field sizes need to be defined at point of measurement most of the time. I'll only give you a TPR table, which refers to the field size at the point of measurement. Therefore, if the point is here instead of being there, the field size here is larger than it is at the surface, which is where the jaws are calibrated at. So when it says a field size 10 by 10 is set, it means it's 10 by 10 only at 100 SSD. Further down, the field size gets larger. So you need first of all to calculate the field size, and then you need to go and look at the various output factors. As if you remember, the output factor only depends on the set field size. The phantom scatter factor depends on the field size at the point. TPR depends on the field size at the point. So far, everybody happy? And then the other thing that needs to happen is that because this point is not at the isocenter, is not in the same point as the calibration of the machine was done, you need to have an inverse square correction, which is the inverse square from 100 to whatever this is, which is 110. Right? Now, when you ask for the percentage depth dose, you need to do a second calculation, which is at this point, which is at the depth of maximum, which is 1.5 centimeter. So you have to do the same calculation again, but instead of being at depth of 10 or depth of 1.5, so the field size is the field size of 10.15, the PR 1.5 centimeter, 10.15, then the inverse square law is 100 over 101.5. I know. So those are subtle differences, but need to be not only made, but shown to be made to get full marks. If this is a kind of question you get in the exam. So you have to do the calculation all over again, and then you get another dose rate, and the percentage is basically the ratio between the two dose rates. So you multiply that, divide by that, and you get 67%. The percentage net dose is a ratio of the dose of the points, and notice, just to strengthen the argument, that since both of these points have this kind of inverse square law factor in them, the percentage net dose will be different if the phantom is somewhere else. And that's why we nowadays don't use percentage step doses, because we don't treat the patient at a fixed distance. We put the tumor at the center of rotation of the machine, and then the SSD keeps changing every time we change the angle of the beam. So the TPRs are the most relevant things to use. Okay, and this, given that, to emphasize the point, we have to do exactly the same, but just remember what SSD has now changed to 120, so field size now 13, not 11, and so on and so forth. And the percentage depth dose is now 69.7, which is a nice way of showing that SSD improves as you go further away from the source of the machine. That's a percentage, that's a ratio of two doses. The actual dose at Dmax, or actual dose rate at the point, is going down a lot, because this number is now a very small number. Everybody okay with that? Don't be shy if you want me to explain a little more. This is your last chance. Yes?
How do we know the depth, the max depth is at 1.5?
Because this is 6 MV. That's the kind of information you carry in your head.
Okay.
Also, as a hint, if you go down to the TPR table, eventually we'll get to it. TPR table, you don't have any information below 1.5. And that is an indication that that's the depth of maximum. Yes?
On that point, which energy beams do we have to know Dmax for? What do you expect us to remember?
Well, 6 MV is the only one I sort of expect to remember, because I kept emphasizing it during the lectures. If there's anything else, there will be a different TPR table which will start at the right depth. And again, I can't remember. Honestly, at the moment, I can't remember what exam question I sent. I'll have to remember what I. Yeah.
Will the calculations be kind of 6 MV or 10 MV stuff? I was doing in one of the fast papers. There's a question on KB dosimetry. Will we need to know anything about that?
Well, everything you will know will be given to you. In other words, if there's a table.
Right. Okay.
Yeah, and you know, the only thing you might want to remember about KB dosimetry, that Dmax is always at 0, so that's an easy number to remember.
Right. That's fine.
Yeah. Now, number 2, question number 2. Anybody had problems with question number 2? Or do you all remember what the definition of the quality index is? Okay. So that was a bit of a trick question, because the answer was yes.
Just on a technicality, when we work out MUs, do you always want it to be, it's not a previous question, do you want it to be rounded up always, or kind of down, or do you have
I don't have a preference. If the math is correct, I don't care what the answer is. In what, you know, but if you put it to about 15 decimal points, I might have a question about how well you believe, how much you believe the accuracy of the machine. But whether you would leave 1 decimal point in and out in the MUs is not important. What's more important is to keep decimal points in these intermediate things, enough of them to get a reasonably precise answer at the end. Good. Well, I think we're going right along. Can I anybody open the window, please? Thanks.
Is this going to be on Moodle?
Sorry?
Is this going to be on Moodle?
What?
The whole
Well, I have to talk to Gary about that. I don't know how to do things.
It is on Moodle, except for the answers
it's
to
on the
those two
forum.
questions.
Yeah.
Last year.
Oh, the one from last year, yes.
It is a Moodle, but you don't find it normally where you find it. It's a box on the right, on the top of the page.
Oh, right.
It's in the recent history.
Yes.
Yeah, it says
You
message.
just click there and you'll find it.
Right.
That's the same Moodle page from last year.
Okay, anybody has problems with number 3? Question number 3 was just remembering the formula for the geometrical penumbra. Yes.
Do you define penumbra from the like the field edge, so kind of halfway through, or do you do the whole lot? Because the question, I came up with half the answer, but I only took it.
The source size is 5 millimeters. The geometric penumbra is
Right. Did you see it?
the razor, yes. It's there, yes. And I know it was there, and then got some. No, geometric penumbra.
Sorry, student.